So in this problem here, we're going to use the laws of logarithms in order to solve these logarithmic problems here. So we're going to go ahead and start with the first one. Now, the first one here, we can see, part A, is it's asked us to express these two logarithms here as a single logarithm to the base A. Now the base is already A, so we don't need to do anything with the base. We just need to use these laws here to combine these logarithms into one. So we're going to go ahead and do that. First things first, we can't combine these two without first removing this 2 in the front. So we're going to use this power rule here, where the number in the front simply goes to the power. So in this case, it becomes to the power 2. So it's going to become log A 3 to the power 2, which is 9, plus log base A 11. Now when you have two logs added together, we're going to use this rule here. They become multiplied as long as they have the same base, which ours do. This is 9, this is 11. 9 times 11 is 99. So the final answer is log base A 99. It's that simple. Move on to part B. Part B says solve 5 to the power x equals 8, giving your answer to 3 significant figures. Now, this is actually demonstrating one of the reasons why we use logs. Sometimes in an equation you have a power that's unknown, that's missing, and you can't find it because it's to the power. So you have to bring the power down to the front. So we're going to use this law here, which brings the power to the front. But you'll notice you have to have a log, and here we don't have a log. But in maths we can multiply both sides by anything. So let's multiply both sides by log base A, or log base 10. So logging both sides, so it becomes log, doesn't matter which base it is, 5 to the power x equals log 8. That now allows us to use the power rule, so we can bring that down. Next step becomes x log 5 equals log 8. So then divide both sides by log 5. So what we get is we get x is equal to log 8 divided by log 5. Not log 8 over 5, not like this. This is different. As we have two logs subtracted. Here we're dividing two logs. That's why it says to 3 significant figures, because you have to do this in a calculator. When you do this in a calculator, you get a value of x is equal to 1.29. So that's 3 significant figures. Now, moving on to part C. C, we have another case of solving an equation. So again, you can see here, we have this log, and this log. There's a minus in between these two, so now we can use the subtract rule. When you have two logs subtracted, they become divided as long as they have the same base. So the left side is going to be log base 2, x plus 1, all divided by x equals log base 2, 7. Now when we have this situation, use this rule here. Log A equals log B, therefore A equals B. So logs almost cancel. So then this equals this, so we can find x. So we have x plus 1 divided by x equals 7. Multiply both sides by x, so the x goes up here. So it becomes x plus 1 equals 7x. Then subtract x from both sides. So it becomes 1 equals, when you subtract x from both sides, that becomes 6x. So therefore, x is equal to 1 over 6. Moving on to part D. Part D is exactly the same as part B. So we start by logging both sides. Log 3 to the power x equals log 5. That allows us to bring the x down, so it becomes x log 3 equals log 5. Divide both sides by log 3. We get x equals log 5 over log 3, which, when you put this in a calculator, gives you a value of 1.46. Now, part E. Again, this is similar to part C, so just solving an equation. Differences here, we have 2. Let's see how we can deal with this. First of all, let's deal with this side here using the subtract rule again, so they become divided by. So we get log base 2, 2x plus 1, all divided by x is equal to 2. Now what that's given us is given us that situation here. Log a y equals x. To remove the log, we say this to the power this equals this. Or this to the power this equals this. That's always the rule. So in this particular case, it's going to be 2 to the power 2 is equal to all of this stuff here. You can even put in a bracket. 2x plus 1 all divided by x. Now, go ahead and simplify the equation. So that becomes 4. Multiply both sides by x, you get 4x equals 2x plus 1. Move that there, becomes 2x. Therefore, in this particular case, x is equal to a half. Simple algebra. Moving on to part F. Part F says, given that log xa equals 2 and log xb equals 3, express ab in terms of x. So we have to multiply a and b. Problem is, a and b now are mixed in with the logs. So we have to, for each one of these, use this rule again to go from the log to no logs, and then just multiply a and b. Starting with this one, always. This to the power this equals this, just like we did here. Exactly the same thing. So that first equation becomes x to the power 2 equals a. We have our a now. Do the same thing here. X to the power 3 equals b. It's very easy. Now we have a and b. It says multiply a and b. So go ahead. A times b is equal to x squared times x to the power 3, which is x to the power 5. That's the answer. We've expressed it in terms of x. Now, moving on to the last problem here. It says write each of the following as a single algorithm. So we're going to go ahead and solve these down here. So g. So again, combine these two, use the addition rule, they become multiplied. So the first one, a, is log base a 50. B, we subtract them, which makes them divided by. 10 divided by 5 is 2. So log base a 2. C, start by using the power rule, so it becomes a to the power 3. Then you're multiplying them because you're adding them, so it becomes 4a to the power 3. So log base a 4a to the power 3. You can start doing it in your head eventually with no calculations. It's very easy. D, the last one, is we're going to take that power there, so it becomes log a 4 to the power 2, which is 16. Now it says here plus, now 1. Now another way of writing 1, if we do that here, we need log base a something is equal to 1. A to the power 1 equals a. So log AA equals 1. So another way of writing 1 is log AA. So that is log AA. Multiply by that there, 16. So it becomes log 16a.